Hi, hi, welcome back. We're going to do section 7.3 today. Um, this looks to be your third and final snow day and by far the longest Christmas break that we've ever had. So we're going to get right back into it. This is the third video in chapter 7, sine and cosine functions. And the objective is to be able to find the sine and cosine of any point on a coordinate plane. And we'll probably also be throwing some tangent in there too. Those are the three main trig functions. Okay, so one thing we always have to remember is SOHCAHTOA. Please remember SOHCAHTOA. Okay, so definitely make sure you remember SOHCAHTOA. All right, so getting right into it. We're going to talk about these trig functions in a kind of a new way now. Okay, so here's our three normal ones. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is, those should look familiar. Okay, so now what we're going to do is we're going to do something a little bit different. All right, so we have an ordered pair or a coordinate plane here with a circle. This should look familiar. This is similar to the unit circle that you've learned about in Algebra 2. And let's say I put a point right over here in the first quadrant. I would hope that you would agree that this is the point xy, where both x is positive and y is positive. We went to the right and we went up. Okay. Now what we're going to do is I'm going to draw a right triangle in this first quadrant. Okay, I'm going to draw straight down to the x-axis, and then I'm going to draw a line straight down. That's not a very good line, so I'm going to redo that one. I'm going to go right from the origin up into my point. So hopefully you see here that we have some sort of a right triangle. Okay, now we have to recognize that this point from the origin to the tip corner of your right triangle, that's a positive x value, and then this is your positive y value, and this is the radius of your circle. Anytime you go from the center of the circle to this side of the circle, that's the radius. Okay, so this would be for a first quadrant. That's your first quadrant triangle. Okay, now let's say we put a point in the second quadrant. Okay, what would the ordered pair be? Now we went to the left, so it's going to be a negative x, but we went up, so it's going to be a positive y. So we still have some sort of a right triangle again. So draw that line to the point, and then we draw a line straight down, and here is our right triangle. Now what do we have here? I'm going to actually move these to the inside of the circles. All right, so this was your positive x. Now, what do we have here? We have a negative x value because we went to the left x. We still went up, so it's a positive y, and this is still our radius. R is always a positive r. All right, next we're going to do a third. So this was a second quadrant triangle. Now we're going to do a third quadrant triangle. So I'm going to put a point somewhere in the third. What is the ordered pair here? It's negative x because it's to the left, and now it is a negative y as well because we're going down. So I'm going to draw a line there to my point, line straight up. We have my right triangle. Now notice we're still going to the left, so this side right here is still our negative x. We're going down to our y, so it's a negative y, and remember this is still r. And then lastly, we can do a third quadrant triangle, and some point over here, which would make this a positive x because it's to the right, and a negative y because we went down. So here is my fourth quadrant right triangle. This is still positive x because we went to the right. This is now a negative y, and remember this is still r. Okay, so these are all of your options. These are all of your options. Okay, now we base our sine, cosine, tangent, however, just off of the first quadrant triangle. So I'm only going to look at this green triangle here. Okay, now the thetas are all of these angles next to the origin. So these are all of our thetas. So we're going to do our opposite and hypotenuses all off of those thetas. Okay, so if sine is opposite over hypotenuse, opposite of theta is y, hypotenuse is r. So sine is your y value divided by your r value. Cosine would be your adjacent over hypotenuse. So adjacent would be your x value over your hypotenuse. So x over r. Oops. And then tangent is opposite, which is y, over adjacent, which is x. So y over x. So as long as you can remember these three pieces of information, so now instead of opposite over hypotenuse, all you have to remember is it's y over r. And for cosine, all you have to remember that it's x over r, and tangent is y over x. You should be pretty good. Okay, so that's where we're getting this information. So depending on what the quadrant is, depends on what your signs of your x and y's are. Okay, so let's look at an example here. It says find the sine and cosine and tangent of the point negative 3, 2. Okay, so the first thing we're going to do is we're going to plot negative 3, 2. Okay, so 1, 2, 3, 1, 2. So negative 3, 2 is 3 to the left and 2 up. Okay, so your first thing you're going to do is plot that point. Then you're going to draw in your triangle. So I'm going to go from the origin to my dot, and then I'm going to go straight down. Okay, so we have to also imagine this circle. These are a little bit harder to draw, but imagine this circle that's going all the way around. There's kind of our unit circle for this problem. All right, now, so we have our triangle, and this bottom side is the third side of it. We have to now label our triangle. So we went 1, 2, 3 to the left, so it's negative 3 because we went to the left, and we went up 2. So we already know our x value, and we know our y value. How are we going to find our hypotenuse, which is the radius of our circle? Well, we do it the same way we always do. You do the Pythagorean theorem. So a squared plus b squared equals c squared. You could also replace it with x squared plus y squared equals r squared, because those are the letters that we're using now. But it's the same exact thing. All right, so we know our two legs are 2 and negative 3. So 2 squared plus negative 3 squared equals r squared, or c, it doesn't matter. 4 plus 9 equals r squared. 13 equals r squared. Square root both sides. So r is a square root of 13. Now, we cannot simplify that, so we're just going to leave it. Okay, so we have our r is the square root of 13. All right, so what we're going to do now is we're going to find our sine of theta, our cosine of theta, and our tangent of theta. And remember, theta is the angle next to the origin. Okay. So it's right there. All right, so let's go back to our sine, cosine, tangent. Remember, sine is y over r. Sine is y over r. Our y value is 2. Our r is root 13. So 2 over square root of 13. So let's get rid of that right now. I think you guys are all pretty good at getting rid of that. So I have 2 root 13 on top. And on the bottom, root 13 times root 13 is just 13. So my sine is 2 root 13 over 13. Cosine is what? Cosine is x over r. So cosine is my x value over r. It's negative 3 over root 13. Oops. Okay, negative 3 over root 13. So really, if I were to multiply that out, what I would get is negative 3 root 13 over root 13. So you're going to have to multiply by root 13 over root 13 again. Okay? And then lastly is tangent. What's tangent? Tangent is y divided by x. So my y value is 2. My x value is negative 3. So 2 over negative 3. Okay? So hopefully this is pretty easy for you. It's not too hard. So this would be a second quadrant triangle. Notice our x value is negative and our y value is positive in the second quadrant. All right, example 2. It says find the sine, cosine, tangent of the point 4, 2. Okay, so first thing we're going to do is plot 4, 2. Okay, 4, 2 is 4 to the right. 1, 2, 3, 4. And negative 2. 2 down. All right, so I'm going to draw my triangle first. I'm going to try to attempt to draw a decent circle in here that goes through. Remember, it's got to touch that point. That's not a very good one, but that's okay. It serves the purpose. You can draw this x-sided. You don't have to, but you can if you want to. All right, so our x value is 1, 2, 3, 4. Our y value went down 2. So remember, you have to put your sign in there. It's down 2. So 4 and negative 2. All right, so that's what we're going to do now is we're going to find our missing side. X squared plus y squared equals r squared. We always need to find this r value. So our two legs are 4 and negative 2. So 4 squared plus negative 2 squared equals r squared. 16 plus 4 equals r squared. 20 equals r squared. Then we square root both sides. So r equals, so let's reduce 20. Okay, 20 would be square root of 4 times square root of 5. Square root of 4 is 2. 5 I cannot reduce, so 2 root 5 equals r. Okay, so that's how you simplify it. All right, so there's my three sides. So once again, we're going to find sine of theta, cosine of theta, tangent of theta. And remember, theta is always the angle made with the origin, so it's right here. Okay, so what's sine? Sine is y divided by r. So we have negative 2 over 2 root 5. All right. So let's get rid of this. We have root 5 over root 5. On top I have negative 2 root 5. On the bottom I have 2 times root 5 times root 5 is 5. 2 times 5 would be 10. All right, I need to move these over. Okay, so when I reduce this, what do I get? Negative 2 over 10 is negative 1/5. So I have negative root 5 over 5. 10 reduces to 1 over 5. Okay? Cosine. What's cosine? Cosine. So sine is y over r. Cosine is x over r. X is 4. R is 2 root 5. So 4 over 2 root 5. Get rid of the root 5. So multiply by root 5 over root 5. 4 root 5 on top. And then 2 times root 5 is just 10 again. So 4 over 10 reduces to 2 over 5. And don't forget your root 5 there. So 2 root 5 over 5. Sorry, I'm cramping that in there. And tangent is the easy one. It is y over x. Let's just make sure we're correct there. Tangent is y over x. So y value is negative 2, x is 4. So negative 2/4, hopefully easy, reduces to negative 1/2. All right, so there we go. It says tangent is y over x. Negative 2/4 equals negative 1/2. Okay, that would be a fourth quadrant example. Y is negative, x is positive. All right, last example, almost done. Example 3 says if theta is in the fourth quadrant, so I'm going to draw a fourth quadrant triangle right away because that's what it told us it is. And it says the sine is equal to negative 5 over 13. So let's recap though. We know that sine is y over r. Okay, so my hypotenuse here, remember hypotenuse r is always positive. So my bottom number is my r, so I have to keep that 13 there. Okay, it's always positive. And what do we notice about our y value? It's in the fourth, so it's negative. So the negative 5 is what I'm going to use for the y value. So then what do we need to figure out here? In order to find the cosine, which is x over r, we need to figure out what our x value is. So we need to do a little bit of Pythagorean theorem here first. Okay, so we're going to do x squared plus y squared equals r squared. Fill in what we know. We do not know x, so I'm going to bring it down. We know y is negative 5, and we know r is 13. Okay, so what do we get here? Ooh, where'd that come from? All right, so equals 13 squared. All right, so x squared plus 25 equals 169. X squared, we're going to subtract 25 from both sides. I get 144. 169 take away 25 is 144. And square root both sides. This one's nice and easy. X equals 12. Okay, so we have all three of our sides. Now we just have to answer the question. It wants to know what cosine of theta is. X over r. What's my x value? X is 12. R is still the same. It is 13. So my cosine is 12 over 13. So if it tells you what quadrant you're in, that's how you know whether your x is going to be positive. Okay, this is a positive x. We went down, so it's negative. R is always positive. Okay? All right, last thing we need to talk about. All right, so this is very important that you realize this. Sine of theta always deals with y values. Sines always deals with y values. Cosine, however, is the opposite. It always deals with x values. So if you remember that sine is y, then you always know that your sine is going to be positive above the x-axis because y is positive above the x-axis. And then below the x-axis, sine or y is negative, so sine is also negative. Okay. Cosine deals with x values. To the right of the y-axis, cosine is positive, and so is x. And left would be negative. Okay, we'll talk more about this later, but this is a nice little chart that shows you if you're in the first quadrant, sine equals positive. If you're in the second quadrant, sine equals positive, third and fourth, and so on. Okay, and then this last one is cosine. If cosine's in the first, you know it's positive. If cosine's in the third, you know it's negative, and so on. Okay, so this is a nice little table to have to show you what sine and cosine values are in certain quadrants. Okay. And then lastly, we have this picture of the unit circle, which we'll be getting to next section. This should look familiar to you. We have the xy plane with all of these angles going all the way around with all these ordered pairs. Okay. The next section we'll be able to learn how to actually figure out what all of these are. I know in Algebra 2 some of you were able to memorize this. We won't need to memorize it. You'll be able to know how to figure it out pretty easily. Okay, using all these angles here, 30, 45, 60, and so on. Okay, so that's next section. Just a little pre-cap to section 7.4. All right, so hopefully you enjoyed your Christmas vacation. I made this video on our third